The overall goal of this procedure is to compare the neural efficiencies of participants completing problem sets requiring spatial ability.
This method can answer key questions in the field of engineering education, such as, can students gain expertise in course content in one semester? Or, how do neurological measurements differentiate when students are solving a problem using spatial ability or when they're solving an engineering problem? The main advantage of this technique is that it provides insight into the efficiencies of the brain, and we can align that information with student performance.
Though this method offers insight into spatial ability and statics problems, it can also be applied into other skill measurements and problem types, such as those found in advanced dynamics.
Demonstrating the procedure will be Bradley Robinson, an undergraduate researcher in the laboratory. Stephen Wood, an undergraduate researcher on our team, will be receiving the protocol that we are demonstrating today.
Begin by setting up the electroencephalography, or EEG, headsets according to the manufacturer's instructions. Keep at least 2 headsets charging at all times for at least an hour prior to each session. Acquire the liquid for dampening the EEG electrodes and an abrasive cleaner for ensuring good contact with the EEG reference electrodes. Next, insert the felts into each casing and use a syringe to saturate them with the dampening liquid. Allow the dampened electrodes to rest. Set up 2 video cameras to measure the participant's behavior. Readjust the cameras once the participant is in place